Now let's talk about linear transformations. Suppose you have two vector spaces like V and W. A function that maps V to W is called a linear transformation if for any two vectors U and V in the domain and any scalar like C, T of Cu plus V is equal to C times Tu plus Tv. So as long as you have a function that satisfies this relation, you'll call it a linear transformation. For example, consider the following function T that maps elements from the plane to three-dimensional space. So here you have a two-dimension to three-dimension. I'm going to define it this way. But to say that, hey, this guy takes on X and Y, and it gives us X, Y, and Z value, which is their sum. So here you have X component, Y component, and here you have the Z coordinates. All right. Is this a linear transformation? Well, we need to check to see if this satisfies here or not. So let us take U to be x1, y1, and V to be x2, y2, both of them in the plane. C is just a scalar, any number. Later on, you can change this field to be, for example, the complex numbers as well. So in general, you can say that, hey, C belongs to a field like F, and you can generally change this to any field F. If you feel comfortable, you can keep it as real numbers, but in general, you can use the field. So let's check to see if left-hand side is equal to right-hand side or not. So we are checking to see if T of Cx1, y1 plus V, which is x2 and y2, is equal to C, T of x1, y1 plus T of x2 and y2. We're basically checking if left-hand side is equal to right-hand side or not. So first, let us simplify this. This guy is T of Cx1 and Cy1 plus x2 and y2. This guy can be written as T of Cx1 plus x2 and Cy1 plus y2. Very good. Based on the definition here, this guy becomes Cx1 plus x2, Cy1 plus y2, and their addition of these two components, Cx1 plus Cy1 plus x2 plus y2. So this is my left-hand side. What about right-hand side? Right-hand side says, hey, I have C T of x1, y1, which is x1, y1, and x1 plus y1, plus x2, y2, and x2 plus y2. You can distribute C into parentheses. So it's just a vector. So here you have Cx1, Cy1, Cx1 plus Cy1 plus this guy here, which is x2, y2, and x1, x2 plus y2. Combine these two vectors together. The first components needs to be added. So you get Cx1 plus x2. Then you move to the second elements, Cy1 plus y2. And finally, the sum of these two, Cx1, Cy1 plus x2 plus y2. This is basically your right-hand side. Are these two equal to each other? The first components, yes. The second components, definitely. And the last components, they are all equal to each other. So what's the meaning of that? So T is a linear transformation.